Good afternoon, everyone. One of the very first things I did when I arrived to Washington, D.C. was to attend a House Select Committee on Intelligence hearing that discussed the national security implications of climate change. One thing became readily apparent at this hearing, that there was a large gap between what our experts knew about something called solar geoengineering and what our elected officials knew. Today, I hope to try to bridge this gap, since geoengineering may be the solution we need to solve one of the greatest challenges that mankind has ever faced. I'm talking about climate change. The vast majority of climate scientists, an overwhelming majority, have now reached the consensus that the warming we are currently experiencing is caused by man. The amount of CO2 in the atmosphere today is greater than it has ever been in human history. Even more concerning, the rate at which the CO2 is entering the atmosphere is greater and more rapid than has ever been observed in Earth's recorded history. The impacts of climate change are wide-ranging and will affect each and every one of us. Although many of the specific impacts are difficult to quantify, there are a few key outcomes that we can almost guarantee with near certainty. These include, and I have a list here, temperature rise, ocean acidification, biodiversity loss, Arctic sea ice loss, extreme weather events, increase in drought frequency, more heat waves, changes in precipitation patterns, and increased forest fire activity. The Intergovernmental Panel on Climate Change has given humanity about 10 years to resolve these issues to avoid irreversible climate change. 10 years, not until the world ends, but until climate change is no longer reversible. If we take a look at this graph here, you will see on the x-axis a range of time from 1940 to 2100. If we take a look at the y-axis, you will see the global change in temperature in degrees Celsius since the Industrial Revolution. If we take a look at the blue line, you will see the warming we have already experienced that has been caused by man, and you'll see that we have already reached about just over 1 degree Celsius in 2017. If we continue along this trend, as shown by the black line, by 2040, we will hit 1.5 degrees Celsius. Now, that 1.5 degrees Celsius orange line there is key because this is the threshold that the United Nations Intergovernmental Panel on Climate Change has recently readjusted and has said we have to fall below this line in order to avoid the most catastrophic impacts of climate change and to ensure climate change will be reversible. In order to avoid this line, we need to fall somewhere within the range of that green area there. So within 10 years, we need to start turning things around or we will hit that point at 1.5 by 2040. So what are we going to do about this? Well, most efforts have been focused on decarbonization, and that's ultimately what emission reduction comes down to. Most of the effort has been focused on solar, wind, electric vehicles, and maybe even nuclear power to supply some baseline energy to the grid. However, there are a whole host of sectors that will need to be decarbonized. These only account for the transportation and the energy sector. Additional sectors such as the manufacturing sector and the agricultural sector will also need decarbonized. But there is one thing in common amongst all of these sectors. They will be costly to decarbonize. Additionally, they're going to take time to decarbonize. Now, I don't have the magic solution today to tell you how to reduce the cost of these solutions, but I do have a potential way that could buy us more time to avoid irreversible climate change. Solar geoengineering. So if we take a look at the Earth, it has an energy balance. We have solar radiation coming in from the sun, and some of that radiation is either emitted back into space or it is absorbed by the Earth. Climate change has shifted the balance of the energy coming in, and we are now absorbing additional energy and emitting less back into space. Solar geoengineering would restore this energy balance by emitting additional energy back into space via increasing the albedo of the Earth, or the reflectivity. How this would work is we would inject the most common method, at least there are many, but the most common and heavily researched area and the most feasible involves injecting a small amount of sulfur aerosols directly into the stratosphere via an airplane. Now, by doing this, we would reflect about 1% of the incoming radiation from the sun back into space, this would reduce the temperature of the Earth back to normal levels. There are a variety of issues that would arise when we talk about solar geoengineering that need to be considered. The first is that there's a fine line between research and implementation. Up to this point, all the research on solar geoengineering has been done via computer modeling and simulations. Now, this clearly falls closer towards research than implementation, but if we consider Harvard's ScopeX project, which will launch by the end of this year or as early as next year, they are considering injecting about 10 kilograms of calcium carbonate into the stratosphere to observe the effects. Now, this would clearly fall closer towards implementation than research in comparison to computer modeling. However, I would argue this is still closer to the research side of the spectrum, given the scale of the experiment. But if we take a look at something like large-scale sulfur injection, this is clearly closer to implementation than research. The point I'm trying to make here is if we go about conducting solar geoengineering research, we need to do it in a way that guarantees we're not going to accidentally implement solar geoengineering as we're researching it. Another issue that arises is the potential for rogue actors using unilateral action to implement solar geoengineering. Solar geoengineering essentially allows us to modify the Earth's thermostat, and each nation may decide they want to set this thermostat at a different temperature. For example, a few decades from now, Africa may decide that the changes they've experienced in the climate are no longer conducive to their agriculture. So they may decide to get together and implement solar geoengineering and inject sulfur into the stratosphere. This may upset Russia, since Russia may be gaining access to resources in the Arctic as it melts due to climate change. This could create conflict. These are the type of conflicts we need to avoid and that are almost inevitable when we consider unilateral action. I'll come back to this later. There are also going to be unintended consequences associated with solar geoengineering. The mechanizations of the climate are incredibly complex, and we do not have a full understanding of them yet. In order to perform a proper cost versus benefit analysis to determine whether it's worth it to implement solar geoengineering or not, we need to determine what the specific impacts will be of solar geoengineering and get a better grip on what the impacts of climate change will be. We don't have either of these quantified quite yet. But before we even consider performing solar geoengineering research, we need to demonstrate, as the United States needs to demonstrate, that we are not going to use solar geoengineering in place of emission reduction efforts. This is important because if we go about continuing to emit carbon dioxide in the atmosphere while simultaneously implementing solar geoengineering, ocean acidification will continue to get worse. Additionally, if we continue to emit CO2 as we solar geoengineer, the concentration of carbon will continue to rise in the atmosphere, and say somewhere down the road a war were to break out, and we forget to put the sulfur in the atmosphere one year. Then all the warming that has been building up over those decades or however many years will hit us all at once and cause a vast amount of instability in the climate. So luckily there's already a framework in place that will allow us to demonstrate to the international community that we want to prioritize emission reductions, the Paris Agreement. Now I'm aware President Trump pulled out of this agreement about 2 years ago. However, he has said that he would be open to renegotiating the terms of this agreement, although that has not happened quite yet. So I would urge the President to renegotiate these terms as he sees fit to allow the United States to rejoin the agreement as soon as possible. I must also note that since this is a voluntary agreement, by verbally withdrawing, the President has essentially pulled out, even though the United States is officially still in the agreement until 2020. So now that we have our goal set of how we're going to achieve emission reductions, we need a roadmap. So I'm sure you are all familiar with Congresswoman Alexandria Ocasio-Cortez's Green New Deal, but there's also Republican Congressman Gates's Green Real Deal. Upon closer examination of these two bills, one will find that there is a large amount of overlap in the goals set. There are differences, but there's a large amount of overlap as well. When we look at things like improvements in building energy efficiency, modernization of the electrical grid, greater resiliency against climate change-related disasters, economy-wide decarbonization, and investment in clean energy infrastructure, these are things that although these two politicians may fall on opposite sides of the spectrum, that they both agree upon. I would propose a Green Deal, a bipartisan Green Deal that merges these two documents to achieve emission reductions in a meaningful way. So now that we have prioritized mitigation and adaptation efforts, I would propose establishing a U.S. federal geoengineering research program. This program should be overseen by the Department of Energy Office of Science, where they will give out grants and fund research to universities and national laboratories across the U.S. Additionally, NASA and NOAA would provide their satellite resources as needed to enhance these research efforts. The Environmental Protection Agency would play a critical role to provide environmental impact assessments on all real-world experimentation, not modeling, just the real-world experiments, to determine the risks associated with the experiments. And ultimately, the EPA would have the discretion to either shut down or give the green light to these experiments after they evaluate the risks. Finally, as I said I'd come back to later, to avoid unilateral action, we need international oversight. I would recommend establishing this international oversight within the United Nations Intergovernmental Panel on Climate Change to ensure multilateral implementation, where each nation would get together and decide whether we were going to implement solar geoengineering or not, so one nation did not have that decision. And ultimately, the United Nations would have to outlaw unilateral action. Every year, the Intergovernmental Panel on Climate Change would provide risk evaluations along with their climate change report so we can properly perform that cost versus benefit analysis I was discussing earlier. And the scientists performing these evaluations could provide recommendations to individual nations on whether it would be beneficial for them to implement solar geoengineering or not, the extent to which it should be implemented, and when it should be implemented. Finally, I would recommend establishing a risk pool where each participating nation in the United Nations would fund an insurance program based upon their GNP so that if an unintended consequence of solar geoengineering were to be experienced by an individual nation, they could dip into this insurance program and mitigate the damages that were caused by it if they could prove these damages were indeed caused by solar geoengineering. The bottom line is, we are all currently participants in the world's dumbest experiment. We are emitting massive amounts of carbon dioxide and greenhouse gas emissions into the atmosphere without a clear understanding of what that will do to our climate. One day, I would hope to be able to hand down the Earth to the future generation with the guarantee that it will remain habitable over their lifetime. I cannot guarantee this right now. Geoengineering may be the solution that will allow me to guarantee this and to finally resolve climate change. Thank you. Before I open up the floor for questions, I would just quickly like to acknowledge the Union of Concerned Scientists, Harvard Solar Geoengineering Research Program, and the Energy Innovation Reform Project, as well as my family for making it all the way here from Louisiana and Pennsylvania, especially my brother Brandon, whose birthday happens to be today.
So yes, we have time for questions. We can between each talk, so I'll open up to the floor.
Go ahead.
So I liked your comparison about how countries can take retaliatory initiatives against another country just because they think they may have made a unilateral decision that impacts their home. So we have policies like WTO, right, that handle these types of things where they make a third-party assessment on whether something done in domestic territory negatively impacted another country's manufacturing sector or mining sector or what have you, whatever Russia is doing. Is it possible, would you consider those institutions robust enough to incorporate an initiative like this, or do you truly need an entirely separate group with an entirely separate process for adjudicating every single concern?
Yeah, so I would argue you need a separate panel because at this point we don't have a good enough understanding about the impacts of solar geoengineering. Say, I don't know, Africa were to get a ton of droughts or something after somebody implemented solar geoengineering. It's difficult to say whether that increased frequency in droughts is due to climate change or solar geoengineering. So we need a very good fundamental understanding of the mechanizations in the climate and what is causing what, essentially. You can't, it's very difficult to differentiate what is caused by solar geoengineering and what isn't. Does that answer your question? Yeah, go ahead.
So a question on the very last point has got to do with setting up a fund.
Yeah, risk pool.
So is that, who's going to do this project? Who's going to build this?
Yeah, so ultimately, I would
do it without liability.
Yeah, ultimately, what would have to happen is in order to participate in the discussions on solar geoengineering, which I'd imagine every nation would want to be a part of, they would have to fund this risk pool to essentially buy into the conversation. And that amount of money, things are still a little gray here of how to actually go about implementing this because it's extremely complex. But at this point, I would argue that that needs to be based upon each nation's GNP, so that way, the cap isn't too high for, smaller nations to buy into the conversation, if that makes sense.
Does that take liability away from whoever's going to, is this a governmental construction project or a governmental project?
Well, this would be within the United Nations, within their secretariat. Did that answer your question? I don't know if that answered it.
The implementation, how would it be used?
Oh, the implementation. Yeah, obviously, the UN, so the UN would have to provide oversight over individual nations. Obviously, one nation would have to implement it, hopefully the United States would be in charge of that. But, other countries would have to actually obviously play a role in that, and there would have to be a lot of oversight in how it's implemented. Something as simple as ensuring the particle sizes of the sulfur we're injecting are in line with what was agreed upon at the United Nations. Those types of things need to be confirmed by probably an independent board. Yeah?
So what do you think is the limiting factor to us understanding the effects of geoengineering? So is it computing power? Is it hard research data like what Harvard's trying to produce? Or is it maybe fundamental understandings of climate science that we don't yet have? What is limiting our understanding?
I think what's limiting our understanding is ultimately awareness. I think many people, even many other chemical engineers I've talked to, don't quite know what this is. And it's a very niche topic that there's only a handful of researchers working on right now. Harvard and Cambridge have the two biggest research centers, but it's something that nations like China is taking very seriously. They have the world's largest solar geoengineering program, and it's something the United States has kind of lagged behind since there's not a federally funded program for this. There's no specific funding anywhere just for solar geoengineering research. And ultimately, there's not a good way to perform a real-world experiment safely at this point. Harvard has set up their own kind of framework to do this with the Union of Concerned Scientists. They've established an independent commission to oversee their experiment. But this is the first ever experiment that would be done in the real world. And so all of our data is just based upon models at this point. There's been plenty of modeling. Modeling is always a good thing. More advanced computer power would definitely enhance that modeling. But at this point, we need real-world experimentation to truly understand what's going on in the atmosphere. Yeah?
With the limited nature of the research on it so far, do you have a feel for how quickly we could get some results and understand if it was actually making a positive or negative change on the environment? Like after the first injection, is it a month, a week, a year? Do you have a feel for that?
Yeah, so we would have to monitor it over the course of, a long period of time. But ultimately, the sulfur only lasts in the atmosphere for about a year or two, and then it dissipates, and it will no longer have the reflective effects. Initially when you eject it, we should be able to, measure it. We've blocked out this much of the sun from coming in. It's about 1% is what would be needed. So we'll be able to initially determine what the effect is of the sunlight, but there are other mechanizations within the climate that will need to be studied until the sulfur is completely dissipated. Something like that they've demonstrated in the models is that when you inject the sulfur in the stratosphere, that could potentially increase the lifetime of methane, which would obviously be counterproductive since methane is one of the most potent greenhouse gases. So these are the types of things that will need to be considered, and you can only get so far doing this with modeling.
And I guess related to that, there have been natural experiments with volcanoes that have
Right. So yeah, I guess I didn't explain this. The solar geoengineering and the sulfur injection in the stratosphere is completely based upon observations of volcanoes that inject massive amounts of sulfur into the atmosphere. So, over the course of a long time now, scientists have observed when a large volcano erupts, the Earth cools a little bit locally. So that's where the idea of injecting sulfur came from. There's a lot of things you could inject, but we know sulfur is already being naturally injected, so we're kind of sticking with that at this point since we already have data that we've already observed.
Quick one. A lot of times when you look at things, this sounds like a great idea, but then you've got two other aspects to it. What happens to the sulfur when it does come out of the atmosphere? Because now you're spreading it over a larger area. And where do you get the sulfur? What are the potential ramifications in terms of mining the sulfur, getting the sulfur in the form that you want to do? So how do you look at those aspects? How do you build those up?
Yeah, so those are two big questions that would need to be answered. Luckily, it's a relatively small amount of sulfur. Obviously, this is also based upon models, so you have to take it with a grain of salt. It's a relatively small amount of sulfur, so there shouldn't be a significant impact in mining, but of course, if you do it over the course of multiple years, it could end up being significant. But yeah, there is a big concern with what happens to that sulfur. Are we going to be seeing additional acid rain and things like that when it dissipates? And that's a big question that the models can't really answer. So that is why you would need more localized experiments to try to answer some of those questions.
Any other questions? Well, with that, let's thank Bradie once again.